All right, and welcome back to Unit 3.3. This is part two, which is the final part. So just to recap, in part one, we defined change in give-free energy, maximum amount of work a system can do. We also, in 1.2, introduced standard formation quantities, and we talked about standard formation reactions, and we also covered standard states in 1.1. So with that being said, we're now going to go into calculating delta G, delta H, and delta S using what's known as Hess's Law. So we sort of introduced this before, and that's why we talked about formations, because as you can see in Hess's Law, we use um, the delta G's of formation, delta H of formations, and S of formations in their standard states. So let's take a look at a problem where we'll be using one of these. And we're going to just focus on delta G, but note you can calculate this for delta H and delta S as well. So it says use the data from Appendix C to calculate the standard free energy change for the reaction below at 298 K. And they gave us this reaction. Is this reaction spontaneous? Explain what is the delta G standard for the reverse of this reaction. So sort of like three parts we have to do. A, calculate our delta G, use the delta G calculate to determine if it's spontaneous or not and explain that, and then determine the delta G standard for the reverse reaction. All right, so let's go ahead and get into calculating the delta G. But before we do that, I want to show you the appendix. So this is linked. So let's just take a moment to look through this appendix together. It says at the top, thermodynamic quantities for selected substances at 298.15 K or 25 degrees Celsius. So this is essentially 298 K, and that's sort of standard temperature. As you can see that in the table, there are four main columns where you have the substances listed. Then you have the delta H, delta G's, and the S standards. And the units are here, kilojoules, kilojoules, and this is joules. And again, of course, it's mole over mole and mole Kelvin. Now, so there's sort of two sides to it. You have this side and that side have the same information, just for different substances. You'll notice that the substances are alphabetized, starting with aluminum, barium, beryllium, etc. And if you wanted to know if you wanted to find a salt here, like calcium chloride, you would have to look under the cation, so under the metal here, and see if it's there. For anything that's like a hydrocarbon, they have carbons. There's a whole big stack of it starting here and then going over on this side, so that's where you find carbon. One of the ones I want to point out for you is where do you find water. You may think you find that under hydrogen, but actually it's under oxygen. So H2O gas, liquid, you have to be careful, make sure that your phases match. If you're dealing with H2O gas, it's going to be different values than H2O liquid. All right, so now that we see kind of like where the substances are, when they're arranged in alphabetical order, in terms of the values, delta H is listed first, followed by delta G, and then finally S. So the first one is H, second one G, and then third one S. And so you just need to be careful about that. For example, if you needed to find the delta G standard formation, you would have to look at the second value. So you either scroll back up to the top and make sure, or you are just really careful of knowing the order of it. So, for example, if I was like, oh, what's the S standard formation for NH3, you'd have to go over to the end here, and that's 111.3 joules per mole Kelvin. So don't forget the units are important. All right, so that's how we read this. So if we go back to this problem, this example, where we're asked to calculate the delta G standard. The work for example one is as follows. First thing is we have the equation. I just rewrote the equation here. And we want the delta G standard. So I wrote down the the equation for that. And then underneath what I did was I just sort of plugged in my information. So we start off with the products, and you've sort of seen this thing before. There are 4 PCl3s, so I'm going to take the delta G of formation of PCl3 and multiply it by 4, the coefficient. And I'm going to subtract from that. There's only one product, so then I can go ahead and subtract from that the reactants, and there are 2 of them. So the delta G of formation of P4 plus 6 times, because there's a 6 here, the delta G of formation of Cl2. And if it's helpful as you're looking at this, you may want to put an index card or something to sort of cover the screen so you can see line by line. All right, once I know what my setup is supposed to look like, I go back to that appendix, that table there, and then I just go ahead and let's see if we can find it here. So this will be under phosphorus. See if we can find the information. And so here's our information. So the delta G standard formation for my product PCl3 is here, negative 269.6, and that's again kilojoules per mole. For P4S white, it's 0 because that's in the standard state. And then the other reactant is also in its standard states, Cl2. If you looked up Cl2, you would see that that would be 0 kilojoules per mole. So I just go ahead and I just plug in that information. 4 times negative 269.6, which is the delta G formation PCl3. These are both 0 because they're elements in their standard state, which you may or may not know. I'll just go ahead and plug that in. And then this, when I do the math, I get this value here. Delta G is equal to negative 1078.4 kilojoules. Okay, the next question is this spontaneous? And the answer to that is yes, and that it is because delta G is negative. And then finally, what is the delta G for the reverse reaction? For the reverse reaction, you just flip the sign. So for the reverse reaction, it's going to be positive 1078.4 kilojoules. All right. So that's sort of the stuff that we did there. You're going to now try it with 2 CFUs, CFU6 and CFU7. Well, actually just really CFU6. So take a moment to read it. There is a correction here though. The balanced chemical equation for the combustion of methane was incorrect on your notepad. Sorry about that. So it should be CH4 plus 2 O2 goes to form, cross out that 3, there should just be 1 CO2 plus 2 H2O. So go ahead and see if you can figure this out. Calculate the delta G first, determine if this is spontaneous or not, and explain that, and then give me the delta G for the reverse reaction. Don't forget, you're going to use that appendix C in the previous, that was shown in the previous slide, and it's also linked in this document. Great, so here's sort of the work that you would do for that. Just take a moment to look at it. Again, it may be helpful to use an index card or piece of paper to cover things line by line so that you can sort of read them on your own. All right, so here's the work for that. If you have any questions, please come to class with those questions. Last CFQ, you're given the delta G formation for NaCl is negative 384.2 kilojoules per mole. What is the delta G standard for the decomposition of NaCl? This is sort of a little throwback, see if you remember it. So you're going to pause the video now and try this problem, and when you press play again, the answer will be revealed. Great, so here's the work. This is one where you have to recognize you're manipulating a standard formation reaction. This is standard formation reaction for NaCl. And so this reaction is, it's actually 2 things. It's flipped. I'm going to go ahead and correct that right now. So this reaction is the flipped version. And it's multiplied by 1/2 or divided by 2. So then in the work here, we're going to multiply it by negative 1/2, and then that makes that positive 192.1 kilojoules. Okay, so that's the work for that. All right, hope you found this video helpful. This is it for 3.3. Have a quality day.